Hello my dear students, welcome to IMS GATE Academy. I hope you are doing great. My dear students, as part of the foundation course, I am continuing the classes on geotechnical. Remember my dear students, the intention of the foundation course is to make your basic concepts very clearly. Not only civil engineering my dear students, in IMS GATE Academy YouTube channel, we are coming live on all the topics on all the branches for civil engineering. Okay. My dear students, the only help you can do, if you really like this session and are you really preparing for GATE exam, then don't miss these sessions on the foundation course. So let us start the sessions today. My dear students, I would like to start the session on compaction. Today's topic I would be like to discuss here is compaction, my dear students. So when I talk about compaction, so first of all, what is the purpose? Why do you want to do compaction? Today's topic is, my dear students, compaction. So why do you want to study about the compaction? Remember my dear students, in soil we have voids. These voids can be air or water. Whenever the voids, very good afternoon Srujana, very good afternoon. When you remove air or water from the voids, the soil particles comes closer. Am I correct or wrong? See, if you have voids in between the soil, suppose see students, if I consider this as the soil particles, in this between, this is called the voids. This region, whatever I am showing with yellow color, is the voids. These voids can be filled with what? It can be filled with air or water. When you remove these voids, my dear students, the soil particles comes closer. So what happens when you do compaction? That is a very important point we have to learn. So first of all, let us understand what is the definition of compaction. Let us understand what is the definition of compaction. My dear students, removal of air from voids, under a short term moving vibrating loads. What my dear students? Under a short term moving vibrating loads, if you are trying to remove the air from the soil, from the voids, then it is called compaction. So see students, see, here I would like to tell you one important thing. When you do damping, so due to the application of the load, immediately the air will expel out from the soil. So what is the compaction is? It is the removal of air from the voids under short-term moving vibrating loads. Remember this word, short-term moving vibrating loads. So my dear students, compaction is a very quick process. It is not a slow process. It happens very quickly and immediately you can see that the air is removed from the soil. So please note down this point, my dear students. Compaction is a very quick process. Now, what happens when you do compaction? See, when you do the compaction, my dear students, void ratio decreases. Permeability decreases. When void ratio and permeability decrease, obviously due to the better bonding between the soil particles, the shear strength will increase, my dear student. The shear strength will increase. So why do you want to do compaction is, see my dear students, we are performing the compaction just to improve the engineering properties. We are trying to reduce the void ratio, we are trying to reduce the permeability and we are increasing the shear strength. Once the shear strength is increased, my dear students, remember that the bearing capacity of the soil is increased. So that is the beauty of compaction. So compaction you might have observed in ordinary roads. You will be seeing rolling of roads. Before laying a pavement, what you will do? They will do rolling and they will leave for some time for settlement. Whatever you do rolling, that is kind of a compaction. So my dear students, please write down the note. Compaction is a very quick process. It is the removal of air from the voids under a short-term moving vibrating loads. So due to compaction, void ratio decreases, permeability decreases, shear strength increases. Now see students, we have different tests. My dear students, we have different tests. One is compaction to test. So why do you want to perform compaction test? Any idea? Any idea? Why do you want to perform the compaction test? My dear students, why we want to perform the compaction test is, first thing is we want to identify the amount of compaction. First thing what I would like to tell you is, why do you want to perform compaction test is, we want to identify the amount of compaction. How much compaction has been done. That means you are trying to find out the dry density. What you are trying to find out? You are trying to find out the dry density. And the second thing what I would like to tell you here is the optimum moisture content. So why do you want to find out the compaction tests? Compaction tests are done to determine the amount of compaction and optimum moisture content. I will explain you optimum moisture content later words. Okay. Just remember, for now, if you want to have an idea, the water content at which the dry density is maximum is known as optimum moisture content. Agree, my dear student? So let us start. So the first one we have is the standard Proctor test. What is the first one we have, my dear students? Standard Proctor test. So when I talk about the standard Proctor test, see students, we have to take first a cylindrical mold. In standard Proctor test, we have to take a cylindrical mold. We have to take a cylindrical mold of capacity how much? 1 liter. Of capacity 1 liter. And the soil is arranged in the cylindrical mold in 3 layers. The soil is arranged in how many layers in the cylindrical mold? The soil is arranged in 3 layers. You can write here, soil is arranged in 3 layers. Okay. Are you following, Srujana? So here in standard Proctor test, you are taking a cylindrical mold of capacity 1 liter and the soil is arranged in 3 layers in the cylindrical mold. Good evening, Tirumala. Okay. Here when I talk about when the soil is arranged in 3 layers, each layer is given 25 number of blows. Each layer is given how much, sir? Each layer is given 25 number of blows. So each layer is given as how many number of blows? 25 number of blows. Now you will ask me here, what is the hammer weight? So each layer was given how many number of blows, sir? 25 number of blows, and hammer weight is 2.60 kg and height of fall is 31 centimeter. Height of fall is 31 centimeter. So here, my dear students, please follow it, very important. Standard Proctor test, here the cylindrical mold is 1 liter and you have arranged the soil in 3 layers and each layer is given 25 number of blows and hammer weight is 2.6 and height of fall is how much? 31 centimeter. Now see students, if I see here, if this is the hammer, if I fall this hammer, what will be the energy conversion, sir? You are falling from a height. So what will be the energy conversion? If you are dropping a hammer from a height h, that will be converted into what energy? that will be converted into the potential energy. So energy imparted or work done, you can write energy or you can write work done by the hammer is nothing but what, sir? Potential energy. Here work done is nothing but it is converted to potential energy because it is falling from a height h. So you can write it as mgh. Now my dear students, what is the weight of the hammer? The weight of the hammer is 2.60 kg. And how many number of blows you are applying here? 25 number of blows you are applying. And how many layers you are doing? You are applying in 3 layers. And what is the gravity? 9.81. And what is the height of fall, students? The height of fall is 31 centimeter. That is 0.31 meter. So when you solve this, what is the value you have converted? Anyone tell me? What is the value you got, sir? This value will be equal to 593.01 Newton per meter. So my dear students, simply you will ask, sir, I am doing compaction, that is standard Proctor test. What is the application? Where do you use this standard Proctor test? And my dear students, if I talk about the standard Proctor test is also known as Indian Standard Lightweight Test. Standard Proctor test is also known as what, sir? Indian Standard Lightweight Test. Indian Standard Lightweight Test is also known as Standard Proctor test. And here what I would like to tell you is, here the soil is arranged in 3 layers. And this Standard Proctor test is applicable in ordinary highways. It is applicable where, sir? This Standard Proctor test is applicable where? It is applicable in ordinary highways. So the application of Standard Proctor test is ordinary highways you can take. Clear, Srujana? Is this clear for you? Now my dear students, coming to the next one is modified Proctor test. The next test we have is the modified Proctor test. So what is actually modified Proctor test? Remember my dear students, modified Proctor test is also known as Indian Standard Heavyweight Test. Modified Proctor test is also known as Indian Standard Heavyweight Test. Indian Standard Heavyweight Test is known as modified Proctor test. Now see students, here also the cylindrical mold is, how much, sir? Here also the cylindrical mold is 1 liter. Here also the cylindrical mold is 1 liter. When I talk about cylindrical mold is 1 liter, here please remember this students, the soil is arranged in 5 layers. In the cylindrical mold, how the soil is arranged? The soil is arranged in how many layers? Here the soil is arranged in 5 layers. Okay. Now see students, here also each layer will be given 25 number of blows. Here also each layer is given how much, sir? 25 number of blows. Okay. Now in this case, what will be the hammer weight? In a modified Proctor test, the hammer weight is 4.90 kg. And height of fall in modified Proctor test is 45 centimeter. How much, sir? It is 45 centimeter. So when I talk about the modified Proctor test, it is also known as Indian Standard Heavyweight Test. Sir, obviously here the compaction will be more because the soil is arranged in 5 layers. Apart from this, we are using the heavyweight hammer, and also the height of fall is also more. So this clearly says that the amount of compaction done by modified Proctor test will be more when compared to the standard Proctor test. Sir, in practical nowadays, if you talk about the practical exposure, everywhere they will be using modified Proctor test. Usually they are avoiding the standard Proctor test. Any application they are using the modified Proctor test. But actually if you see the airport runways, when I talk about airport runways, or when I talk about the airport runways, or if you talk about the express highways, if you talk about the express highways, when I talk about the airport runways, or if I talk about the express highways, then in the both the cases, remember students, we are going with the modified Proctor test. So here, my dear students, I would like to tell you, the soil is arranged in 5 layers and each layer is given 25 number of blows. Hammer weight is 4.90, height of fall is 45 centimeter. Now see students, what is the work done? Work done in case of modified Proctor test. Work done in case of modified Proctor test. Work done in case of modified Proctor test is given as mass into gravity into height. Potential energy, sir. What is the mass? 4.90 kg. And how many layers? 5 layers. Okay. And how many number of blows? 25 number of blows. Into gravity is 9.81 and height of fall is 45 centimeter. We can convert into 0.45 meter. Now can you please anyone solve this and tell me what is the value you got? You have to check them. You please check it. I am writing the answer 2703.88 Newton per meter. Have you got this answer or not? Please check. Have you got this, Srujana? What is the value of modified Proctor test? Work done in case of modified Proctor test is 2703.88. 4.9 into 5, it will be around 24.5. And 24.5 into 25, it will be around 612 or 620. And into 6000 into 0.5, you will get 2703.88. Have you got this value, sir? Sir, there was a famous question, Amma. Sir, there was a famous question here. The modified Proctor test. Sir, see, this was a previous IES question, Amma. Or if you see, as you are seeing the ISRO exam also, these kind of questions can be observed there also. When you talk about a modified Proctor test is 4.55 times the modified Proctor test compactive effectiveness. We call this as the compactive effectiveness. Sir, work done or something, we call it as what, sir? The compactive effectiveness. Okay, how much effort you are doing for making the compaction, or how much work you are performing to do the compaction. When I talk about, very good Bal Subramani. So when I talk about the modified Proctor test, the compactive effectiveness is 4.55 times the standard Proctor test. 4.55 times the standard Proctor test. Sir, how do you got 4.55 there? Can you tell me how do you got 4.55, my dear students? See, this 4.55, you know, the modified Proctor test compactive effectiveness is 2703.88 divided by 593.01. If you solve this value, you will get a value of 4.55. Okay. So this is how this you can write it as a note. It was way back asked in IES also, in SSC JE also, and all the other competitive exams. So please write down the modified Proctor test is, the compactive fitness of modified Proctor test is 4.55 times the standard Proctor test. Very good, Srujana. Very good. Now see students, let us see note, another note. See students, here if suppose, see if the percentage of soil retained, if the percentage of soil retained on 4.75 mm is more than if the percentage of soil retained on 4.75 mm is more than 20 percentile. Sir, what does this statement says? First of all, let us understand Balasubramani, what I would like to tell you here is, first of all, try to understand. There was a question that if the percentage of soil retained on 4.75 mm is more than 20%. So, whatever the amount of soil is retained on 4.75 mm is more than 20%. So, this soil indicates it is somewhat coarser. So, my dear students, what happens here is, see, please understand this clearly, my dear students. Here what happens is, if you talk about the size of the soil particles, the size of the soil particles are coarser. So, if you take the size of soil particles will be coarser. So, if I take 1 liter, so the best example, the best practical example is, suppose if I have taken 1 liter cylindrical mold. So, hardly there will be very few soil particles it will be present, and the test results might not be favor you. The test results will not favor you because you have taken very small sample. Because less number of particles are present, you can place very less number of particles in cylindrical mold. So, when the percentage of soil retained on 4.75 mm is more than 20%, in that case, the cylindrical mold will be increased from 1 liter to, 2.25 liters, and number of blows will be increased from 25 to 56 number of blows. So, please write down this point as a note, my dear students. If the soil particles are coarser, how do you say coarser? According to the compaction is, if the percentage of soil retained on 4.75 mm is more than 20%, then you have to increase the cylindrical mold from 1 liter to 2.25 liter, and also the number of blows are increased from 25 to 56. So, my dear students, if you are really like this session, please share this session and please watch our IMS GATE Academy YouTube channel. You have beautiful, my dear students, any latest notification, whether it is NPC, NTPC, HPCL, BHL, ONGC, all the notifications are detailedly explained in the IMS GATE Academy YouTube channel. Apart from this, we have a wonderful team for all the branches, and please visit our website IMS GATE Academy and also our YouTube channel IMS GATE Academy. Definitely, our motto, our intention is very clear, my dear students. We want you, the real GATE aspirants, to be success in their GATE exam. So, let us move on to the next point. So, when I talk about the percentage of air voids, you know what do you mean by percentage of air voids? Percentage of air voids is defined as volume of air upon total volume. So, when I talk about the total volume, students, see, please follow this, very important, my dear students. When I talk about the total volume will be considered as volume of voids plus volume of solids. Here, when I talk about the volume of voids, there are two things again here. One is volume of air plus volume of water plus volume of solids. So, volume of air plus volume of water plus volume of solids is equal to how much, sir? Total volume. Very good, Balasubramanian. Thank you for the response. So, volume of air upon total volume is equal to volume of water plus volume of solids upon total volume is equal to 1. So, here I have told you clearly, my dear students, what is volume of air upon total volume? It is nothing but the percentage of air voids. So, volume of water plus volume of solids upon total volume can be written as 1 minus Na, where Na represents the percentage of air voids, where Na represents what, sir? Percentage of air voids. And remember here, gamma W is equal to what, sir? Weight of water upon volume of water. So, here volume of water can be written as weight of water upon gamma W. Similarly, my dear students, gamma S, you can write here. Gamma S is what, sir? Unit weight of solids. Sir, if you have not watched my properties of soil, I have explained there also. Gamma S is weight of solids upon volume of solids. And here you can write volume of solids is equal to weight of solids upon gamma S. So, just plug in these values, students. You know the VW and VS, and just plug in these values in the equation. So, here you can write 1 by V. What is VW, my dear students? Weight of water upon gamma W. What is Vs? Weight of solids upon gamma S. Weight of solids upon gamma S is equal to 1 minus Na. What is Na? Percentage of air voids, my dear students. So, let us take weight of solids common and also gamma W as common. When I take weight of solids as common, here there is no weight of solids. You can write it as weight of water by weight of solids. As gamma W is constant, I have taken out. Now, weight of solids is there here. So, there will be gamma W upon gamma S is equal to 1 minus Na, where Na represents the percentage of air voids, my dear students. So, here, what do you mean by weight of solids by total volume? Subramanyam or Srijana, can you tell me what is weight of solids by total volume? Sorry. What is weight of solids by total volume? Quickly reply, my dear students. It is nothing but the dry unit weight. It is nothing but the dry unit weight. So, gamma D upon gamma W. Remember, if you want to have a clarification, dry unit weight is nothing but weight of solids upon total volume. Again, my dear students, what is weight of water by weight of solids? Anyone quickly answer, my dear students. What do you mean by weight of water by weight of solids? Weight of water upon weight of solids is nothing but the water content. Weight of water upon weight of solids is nothing but what, my dear students? It is nothing but the water content. And remember, based on the water content only, you can understand the moisture content also. Okay, so weight of water content is defined as weight of water by weight of solids, and this can be written as WC. And remember, here they have given gamma W by gamma S. Very good answer, Srujana, very good. Now, you know already what is specific gravity. The true specific gravity is defined as the ratio of unit weight of solids to the unit weight of water. The ratio of unit weight of solids to the unit weight of water is known as true specific gravity. And here you can write gamma W by gamma S as 1 by G is equal to 1 minus Na. Upon when you solve this equation, my dear students, you will get gamma D, dry unit weight, is equal to 1 minus Na into gamma W into G upon 1 plus water content into G. So, this is the equation. So, this is the equation for what, my dear students? This is the equation for dry unit weight or dry density in case of the air voids. Sir, why you have derived the formula in terms of air voids? Because compaction will tell you that it is the expulsion of air from the voids. As you are discussing about the air, we have derived the dry density with respect to the percentage of air voids. Are you following, students? Okay. Now, let me explain you one important graph, Amma. Let me explain you one important graph. Now, see, students, a graph is drawn between dry density and water content. A graph is drawn between dry density and water content. Students, if you can understand this graph, you can easily understand what is optimum moisture content and all. For now, see, just observe this graph carefully. It is a graph drawn between dry density and water content. Okay. A graph drawn. So here, if you see here, the dry density is maximum. The dry density is maximum here. If you see from this graph, here also dry density is maximum. And these points are called as optimum moisture content. What is OMC? Optimum moisture content. So this is for standard Proctor, this is for modified Proctor test, and this is for standard Proctor test. And we also have a line like this. What is this called? You might have studied. What is this called? Zero air void line. We call it as zero air void line. Now see students, I want to tell you one important thing. Sir, please observe this graph. What are the observations you have understand this graph? Can you let me know? A graph is drawn between dry density and optimum moisture water content. So what are the observations you have understand from the graph? Can anyone tell me, my dear students? I would be very happy. From the graph, tell me any few observations. Quickly, my dear students. Can you tell me any observation, my dear students? Zero air void line, very good. Zero air void line is also called as, means air content is 0 or 100. Sir, please see here. One thing what we have observed is, as water content is increasing, dry density is increasing, reaching a maximum value and again decreasing. That is the one observation I have observed. Okay. As water content increases, dry density increases, reaches a maximum value and then decreases. Agree? Now, what is the observation you have observed? This is modified Proctor test and this is standard Proctor test. Now see students, even at lesser water content, you are finding maximum dry density in case of modified Proctor test. Even at higher water content, the dry density is less when compared to the modified Proctor test. Sir, this is the major reason why people are going with modified Proctor test. What made people to start thinking about modified Proctor test? What are the advantages of modified Proctor test is, at lesser water content, you are getting dry density more. But even the water content is more, the dry density is not more. So this observation has made the practical observation that in the field, whenever you are using for ordinary highway or a airport runway or express highway, people are going with the modified Proctor test because at lesser water content, the dry density is maximum. Agree students? So this is very, very important. Agree? Any doubts, Srujana and Balsubramani? Okay. Next, see students, let us understand from this graph, these are the key points. As water content increases, dry density increases, reaches a maximum value and then decrease. And another observation you have to tell me is, even at lesser water content, the modified Proctor test is having high dry density when compared to the standard Proctor test. Is this clear? Can you quickly respond, my dear students? Is this clear? Can I move on to the next point? Can you quickly respond, Srujana and Balsubramani? Okay. Next, what are the factors affecting compaction? What are the factors affecting? Sir, after in GATE exam, my dear students, I am telling you, name the subject, any subject. After GATE exam, recently from past 3 to 4 years, we are seeing multiple select question. MSQ, what we call MSQ, multiple select question. In the multiple select question, if you were on to answer the right answer, you should know the concepts very clearly. If your concept is not clear, MSQ problem is a very, very tough. So please understand the concepts very clearly. Now, what are the factors affecting compaction? What are the factors affecting compaction, sir? First assumption, first factor is what? Water content. Sir, compaction means nothing but dry density, amma. For your information, if anyone asks you what is compaction means, improving dry density. So, as I told you already, as water content increases, dry density increases, reaches a maximum value, and then decreases, reaches a maximum value and then decreases. So here what I would like to tell you is, as water content increases, dry density increases. Okay, it reaches a maximum value and then decreases. That is called the water content. That is the reason if you see the graph, it is like this. Okay, next, the next point here is compactive effortness. Sir, this is very, very simple, amma. See, already I told you modified Proctor test is having high compactive effortness when compared to standard Proctor test. That is the reason it has high drain density when compared to SPT, standard Proctor test. Okay, compactive effortness increases. As compactive effortness increases, what happens to dry density? As compactive effortness increases, dry density also increases. As compactive effortness increases, what happens to dry density? Dry density also increases. Is this clear, sir? Is this clear? So, first observation is water content increases, dry density increases, reaches a maximum value and then decrease. Second observation is, as compactive effortness increases, dry density increases. Okay, that is the important point I would like to add. Now, sir, I will tell you the third factor. You have to tell me, Srujana or Bal Subramanyam, you have to tell me this observation. What I would like to tell you is, pure sands don't have well-defined OMC. What is this meaning, sir? Sir, I want any one of you, pure sands don't have well-defined OMC. So let us understand first of all, what is OMC? I forgot to tell you, amma, but I have shown you. This is called OMC, I told you. And this is the dry density maximum. Now see, students, what is OMC is? OMC is nothing but optimum moisture content. OMC is what, sir? Optimum moisture content. You can write here optimum moisture content means, what do you mean by optimum moisture content? It is the water content at which the dry density is maximum. The water content at which dry density is maximum is known as optimum moisture content. You can write, my dear students, what is optimum moisture content? The water content at which the dry density is maximum is known as OMC or optimum moisture content. I hope you are clear. So here I have written pure swans don't have well-defined OMC. What does this meaning is? See, students, if I have drawn a graph between dry density and water content, in case of pure sands, the graph will be like this. Now, can you tell me at which point dry density is maximum? You cannot plot very clearly. Sir, that this is the point where the dry density is maximum. You cannot mention. You cannot mention at which point the dry density is maximum. That is the reason he has given that pure sands don't have well-defined OMC. So this observation will help you in the factors affecting the compaction. Clear, my dear students? Is this clear, Amma? Now, my dear students, I would like to talk about the modified Proctor test. Sir, see, and as modified Proctor test, you name airport, runways, sir, where the compaction should be good. Because even, sir, actually when you talk about transportation, sir, if the compaction is not proper, what happens is there will be payment unevenness. Suppose the payment should be flat, okay? Instead of flat, the payment might be like this. Sir, when the payment unevenness, see these bumps. If the bumps are more, what happens is there are more chances of overturning the vehicle. So in that case, the compaction plays a very important role. So my dear students, in practical, everywhere we are trying to use the modified Proctor test. So this modified Proctor test is helpful in case of airport runways, or also it is very much helpful in express highways. So in these two cases, or any practical observation nowadays, we are going with the modified Proctor test. The reason is simple. The reason is simple, my dear students. The reason why it is simple is you are going with the compactive effectiveness. As modified Proctor test is having high compaction, high compactive effort, then definitely rolling will energy is more, definitely more compaction can be done. Now, the next thing I would like to tell you, Amma, there is also one more observation. What I have observed is, suppose see students, I am just giving an example. See, suppose this is clay, this is silt, and this is gravel. My dear students, in the match the following or in the observations, what I have observed in the graphs is, as the size is increasing, see, clay is lesser in size when compared to silt, and silt is lesser in size when compared to gravel. So gravel size will be more when compared to silt, and silt size will be more when compared to clay. So here what is observing is, here the thing is very simple. Here the thing is very simple. The dry density is more. What, sir? Here the dry density is more. If you consider here, what is the dry density? The dry density is more even at lesser water content for gravel. If you observe for silt, the dry density is less even at higher water content. If you observe for clay, the dry density is less when even at higher water content. So what is the observation we have done? Sir, are you following, my dear students? What is the observation I have observed is, dry density increases with particle size also. And see, you can write here from the graph, very important thing, Amma, dry density increases with particle size, dry density increases with particle size even at lesser water content. And see students, even this is the case. If you see, my dear students, very good Srujna, very good. Are you following? Sir, this, if you see the same graph, if I consider the same graph, instead of this is highly plastic, sorry, there are two particles, one is clay and this is also clay. This graph is for low plastic clay. Sorry, this is for high plastic clay. And this is for low plastic clay. So what I would like to tell you is, as plasticity increases, dry density decreases. So this observation also can be asked in the graphs. And one more thing, my dear students, if you talk about the graphs, not only about plasticity, if you talk, this is well graded sand, okay, well graded, and this can be poorly graded. So what I would like to tell you, my dear students, the dry density for well graded soil, is observed even at lesser water content, high dry density. But in case of plasticity, at high plasticity, even at higher water content, you will observe lesser dry density. So you can write dry density is proportional to inversely proportional to plasticity, inversely proportional to higher the plasticity, lesser the dry density. And you can write dry density is proportional to grading. Grading means if it is well graded, the dry density will be more. If it is well graded, what sir? The dry density will be more. So these things you should be very clear, Amma. So these things you should be very clear. Sir, these graphs will definitely help you to solve some of the objective questions. Now let us understand a concept called placement water content. What sir? There is a concept called placement water content. So when I talk about the placement water content, what do you mean by placement water content, sir? It is the water, or it is the placement water content means it is the amount of water which is used in the field. It is the amount of water which is used in the field. It is the amount of water which is used in the field. It is the amount of water which is used in the field for compaction. It is the amount of water which is used in the field for compaction. The amount of water which is used in the field for compaction is known as placement water content. Suppose, see students, you are laying a road. In case of laying a road, what you will do? They will do some watering and they will do rolling. Or if you see in a IPL match, or previously, you know the curator of Jharkhand, Ranchi, and in that also when they are making a pitch, they will do some rolling, and in that rolling, if they have more grass, then it is more prone to bowling. So in that case also, if over rolling also has been done, then it will be more helpful for the bowlers. So that is a total different concept. For now, just remember that the amount of water which is used in the field for compaction is nothing but the placement water content. Okay, so let us see. We have a concept called relative compaction. We have a concept called what, sir? Relative compaction. Now, what do you mean by relative compaction? Sir, see, I have told you, when you study about relative density, you will also have an idea about relative compaction. What do you mean by relative compaction is, it is the ratio of dry density in the field upon dry density in the laboratory. It is the ratio of dry density in the field upon dry density in the laboratory multiplied by 100. So this is known as relative compaction. So how the layers, one layer by another layer, how they are compacted, that itself is nothing but relative compaction. Or relative compaction, it is the ratio of dry density in the field upon dry density in the laboratory into 100. Similarly, we have a test called Proctor needle test. What, sir? There is a test called Proctor needle test. Okay, what do you mean by Proctor needle test here is, sir, see, a needle, suppose if you find this as a needle is pushed into the soil for a depth of 7.5 centimeter. What, sir? A needle is pushed into the soil for a depth of 7.5 centimeters. When the needle is pushed into the soil for a depth of 7.5 centimeters, what happens is a resistance will offered. So when you push the needle into the soil, if the soil is very hard, you cannot push the needle easily. The resistance will be offered. If it is a loose soil, then if you push the needle, then it will easily go. So what here is, using the resistance, if the resistance is more, then it is a dense soil. If the resistance is less, then it is a loose soil. It's a kind of preliminary test. By basic sense, you can understand what is the type of the soil. So what is Proctor needle test is, you can say a needle is pushed into the soil, a needle is pushed into the soil for a depth of, a needle is pushed into the soil for a depth of 7.5 centimeters, for a depth of 7.50 centimeters. And the resistance offered by the soil, what sir? And the resistance offered by the soil, and the resistance offered by the soil is, and the resistance offered by the soil is measured. Okay, so this is known as Proctor needle test. What is a Proctor needle test? A needle will be pushed into the soil, and if there more resistance is offered, then it is a hard soil. If it is less resistance is offered, then it is a loose soil. Now, my dear students, we have different equipments. We have different equipments to determine the compaction. Sir, see, when I talk about vibrators, equipment called vibrators, vibrators are best suitable for sandy soils. They are best. They can ask you in the match the following. In one of the GATE exam, they have asked, sir, which is the best equipment for compacting sandy soils is vibrator. The next one what we have is sheep foot roller. Sheep foot roller is best in case of cohesive soils. Cohesive soils means you can write it as clayey soils. Now, my dear students, if they ask you, name the equipment which is useful for both cohesive and non-cohesive soils or cohesionless soils, then it is pneumatic rollers. Pneumatic rollers is best suited for both cohesive and cohesionless soils. It is best suited for cohesive and cohesionless soil. So this is what actually the equipments. We have different equipments also. These are the one which are very important. Sands, vibrators are the best. For sheep foot rollers, we are applying for clays, and pneumatic roller is for cohesive and cohesionless. Sir, for example, the soils like clay is nothing but a cohesive soil, and when I talk about the cohesionless soils, the answer is nothing but sand and gravel. So for any type of soils, you can apply with pneumatic rollers, sir. Sir, what is this sheep foot roller? And sir, basic terms, when you do ploughing, when there is a paddy especially in the southern part, wherever they do cultivation in the or in the growth of paddy or in the growth of sugarcane, they do ploughing. You will see some grooves like this at the end of the tractor. Those are nothing but the rollers, where how do they do compaction and all. And apart from this, we have another important term, Sama. One is dry off optimum, and we also have a term called wet off optimum. We have terms called dry off optimum, and we also have a term called wet off optimum. Sir, see, when I talk about dry off optimum, sir, what actually is dry off optimum is if the amount of water added is less than OMC. Suppose, see students, you have told the graph here, right? This is the point where it is, the water content is, this is the point where dry density is maximum. This is the point where what, sir? Dry density, this point is where the dry density is maximum, and this is called what, sir? OMC, that is optimum moisture content, or you can write the water content at which the dry density is maximum. The water content at which the dry density is maximum is known as what, sir? Optimum moisture content. So here what I would like to tell you, very important thing is, my dear students, what is dry off optimum is if the amount of water added is lesser than to reach the OMC. This portion, whatever this, because this portion is lesser than the amount of OMC, that is called dry off optimum. If the amount of water added is more than the amount of water required for OMC, then it is called wet off optimum. So here what I would like to tell you is dry off optimum will have more swelling and more shear strength. Wet off optimum will have less swelling and less shear strength. But still, as it is having less swelling, that is the reason if you take an earthen dam or anything. Are you able to understand? I repeat the thing again. If the amount of water is less than the amount of water required for OMC, then it is dry off optimum. If the amount of water is more than the amount of water required for OMC, then it is wet off optimum. So dry off optimum will have less swelling and less shear strength. Wet off optimum will have more swelling and more shear strength. And as dry off optimum is having less swelling, definitely it will be used in the core. If you are implementing core of an earthen dam, in the core where the settlement should be less or where you are finding less swelling. In that case, you are using the compaction. Sorry, there you will be using dry of optimum. So here I'll quickly write the summary of compaction. Okay. So let me complete you very fastly. And as we have discussed, remember students, what is actually compaction? Compaction is the removal of air from the voids under short-term moving vibrating loads. It is a very quick process. By applying the compaction, the engineering properties like permeability, void ratio decreases and shear strength increases. We have two types of test. One is standard Proctor test and modified Proctor test. In case of standard Proctor test, the soil is arranged in 3 layers in a cylindrical mold of 1 liter and each layer is given 25 number of blows. The hammer weight is 2.60 kg, height of fall is 31 centimeter. So the compactive effectiveness in case of standard Proctor test is 593.01 Newton meter. In case of modified Proctor test, the soil is arranged in 5 layers and each layer is given 25 number of blows. Hammer weight is 4.90 kg and height of fall is 45 centimeter. And the compactive effectiveness in this case is 2703.88 Newton meter. And remember, my dear students, according to very important, the modified Proctor test compactive effectiveness is 4.55 times the standard Proctor test. And another important point is if the percentage of soil retained on 4.75 mm is more than 20%, in that case the number of blows will be increased from 25 to 56 and the cylindrical mold is increased from 1 liter to 2.25 liters. What are the factors affecting compaction is as water content increases, dry density increases, reaches a maximum value and again then decreases. Pure sands don't have well-defined OMC, and remember, compactive effectiveness increases, dry density increases. And placement water content, it is the water content at which dry density is maximum. Relative compaction, it is the ratio of dry density in the field by maximum dry density in the laboratory. And Proctor needle test, it is the needle. If a needle is pushed into the soil for a depth of 7.5 centimeters, a resistance is offered. Based on the resistance, you will classify whether the soil is dense or loose. And what are the different equipments we have is vibrators are the best for sands, pneumatic rollers are best for cohesive and cohesionless, and sheep foot rollers is best for cohesive soils. And when I talk about the dry of optimum, the amount of water added is less than the OMC, and if the amount of water added is more than OMC, then it is wet of optimum. And remember, my dear students, the important formula here is gamma D is equal to 1 minus Na into gamma W into G upon 1 plus water content into G. I hope you are clear with the compaction. And remember, my dear students, I hope I have seen some of the students who are attending the classes regularly. That is a very good thing, my dear students. And the other part I would like to tell you, if you are really a student of Bangalore preparing for GATE, or if you are a student of Vijayawada, definitely we are offering the offline centers at IMS GATE Academy, at Bangalore, at Jayanagar office. Please visit our center and have the feel of the demo classes, and if you are really interested, then you can take admission. And we at IMS GATE Academy providing 800 plus hours, and we are giving one-to-one mentorship programs of around 12, and we are providing the theory books, exercise books, chapter tests, multiple subject tests, and we are monitoring the students in day-to-day analysis, and this will definitely help the student to qualify. And we have lot of results with our GATE Academy. And remember, if you are a student from Vijayawada, don't miss IMS GATE Academy at Ben Circle. I hope this session is helpful for you, and any clarify of doubts you can comment in the comment box, and definitely we are ready to help you. And remember, my dear students, IMS GATE Academy, if you visit the website imsindia.com, IMS GATE Academy, then definitely there is a program called GATE Zero Fee program. Once you enroll in the GATE Zero Fee program, you have 100 of plus hours of recorded lectures. You can understand how we teach at the classes, and also you can have 6 subject tests and 6 previous year GATE questions. And definitely these sessions will help you, and the overall motto of the fundamental course is make your basics strong, and definitely you will be in the right line. And if you are preparing for ISRO also, definitely, my dear students, this foundation course will definitely help you. And thank you. If you have any queries, you can ask me in the chat box. If you don't have, with this we are done. See you tomorrow with the very, very important session. Tomorrow don't miss this session, and I promise you in the coming GATE 24 exam, definitely you will get 2 marks from consolidation. Thank you and all the best.